Hello. Okay, let's start. My name is Hamilton. Today I'll be taking charge of the WA2 revision for differential applications. I'm sure you all received the worksheet. Can I have a show of hands, like just react lah, if you got the worksheet? Cause I scared like you all don't have, then I'll send it to the group. Can, right? Okay, wait, is it recording? Okay, can. Okay. Okay. Uh, Based on experience, I don't think I will take the full 1.5 because there are only 6 questions, but I'll go through a bit slower so that I can cater to like whether you have learned this topic or not, or like you have already mastered this topic or it's your first time now, because different schools go at different pace. Uh, just bear with me for a bit. I got a bit of a pubs thing to go through. So here, these are the slides for the WA2 revision. Just a bit of background on myself. I'm just a new tutor at OVERMUGGED. I teach A Math, E Math, and primarily H2 Math lah. So I think most of my classes are JC. I have around 8 years experience in teaching PCME, mostly math. Then, yeah, I started quite a while back in my early uni days. Then I pivoted to various tuition centers. Eventually, I found Overmark lah, and it's one of the tuition centers that I feel that is the strongest in terms of like the tutors as well as like the material compared to like the other centers that I've taught in. Personally, the value for my classes, even though I teach a wide range of classes, I have my own personal summaries for every topic for math lah, in whichever class I teach, but I only provide these to my own students. So if you want these summaries or like you like prefer like you like consult. So for me it's like I usually have consults for my students also because in class there's not a lot of time to go through school questions in addition to the center question because center question already too much already. So yeah, I usually offer free online consults to my students to just go through the school questions or to prep for WA lah, subject to like time availability. So yeah. Can yeah, just a bit about Overmark. We have like 8 centers primarily here scattered around Singapore. So they're mostly around like the school district. So mostly where like a lot of students mostly will find it convenient. Most centers are also very close to the stations. So you don't have after you get to like say Woodlands MRT, you just need to like walk for max 5 minutes. You should be able to reach kind of the center already. Yeah. So yeah, our proven track record would be that 70% of our students achieve A's in like national exams, and this has been like a year on year kind of consistent kind of results lah that we are seeing backed by data. So and we attribute this to the fundamental like reasoning being that our tutors are experienced. Most of them are ex-MOE or like ex-learning lab with like experience to know what works and what doesn't for when it comes to like effective learning. And yeah, so I will send out these slides in like say the chat. Then if you need more information regarding like say the group tuition classes and the time slots and the availabilities for each subject, and yeah, so this is for secondary level lah. So later I'll send this maybe during the break or something. I'll send it during in the group chat so that you can like scan the QR code and get more information if you need. Yeah. So I'm like somewhere here, small. Wait, I circled the wrong thing. Yeah. I'm like small here and there. I don't really teach secondary. Most of it is JC, but yeah, can. Okay, let's move on. Let's move on to the content for today. So, anything if you need assistance or you need to talk or what, just unmute and say okay. So, it's easier lah for me and easier for everyone also. So, yeah, today I'll just go through a little bit on differentiation applications. So, applications of differentiation lah. So, the prerequisite for this topic is that you already have a good knowledge for differentiation. So, I won't be going through that in depth, like for example, product rule, chain rule, etc. Because I assume that it's stuff that you already know. But then in the event that you are not sure, you can just pause or recap and just ask me like, hey, like how to do product rule. Then I'll gladly write the formula at the side for you to assist you to continue doing the question. So yeah, but I'll be focusing more on the applications of differentiation today because that's the main agenda for why you all come for this lesson. So yeah, first one we talk about say what is the principle of dy dx. So say we have a function y equals to fx. This is actually more on differentiation now, I guess. Then we look at wait, I want to see my own face. Okay, can. Okay, so we talk about differentiation in general. You all can see my screen, right? Is it okay? Can give a thumbs up if you can, if it's okay. Can see my screen or cannot? Can okay, can. Okay, let's start. Yeah. So say we have a function y equals to fx, then when we are finding say y equals to f prime x, or we can say dy dx, we are finding the gradient function of a graph. So say we have a curve, the curve has a certain gradient at each of the points, each of the x values. So every single x value has its own gradient. If it's a straight line, it's very easy for us to find the gradient because straight line has constant gradient. But then when it's a curve or it's a non-linear function, then it's a bit hard for us to find dy dx at each point. So therefore, we need to find this thing called the gradient function. Once we have the gradient function, we just sub the x value corresponding to the point that we want to know the gradient, then we can get the gradient at that point. So gradient function is very useful, and this comes from differentiation techniques, like why we want to find the gradient of a gradient function of a y equals to fx in the first place. So we look at the first part, which talks about increasing and decreasing functions. Increasing functions and decreasing functions basically correspond to dy dx being more than 0 and dy dx being less than 0 respectively. So in layman terms, what does increasing function mean? It just means that a function where the graph is increasing. So something like this is an upward sloping graph. So yeah, it's an increasing function. Decreasing functions are where gradient is negative, so it's a downward sloping graph in layman terms. Stationary points are points where the gradient is 0. So if you look at, say, the peak, the max point here, or the mean point, or stationary points or inflections, these points are where your dy dx is equals to 0, because at that point, instantaneously, so say this point instantaneously is our max point, the gradient is 0. So if I draw a tangent here, I can see that it is instantaneously the gradient is 0 because the tangent is horizontal. Can For stationary points, I just want to elaborate a bit. How do I determine the nature of stationary points? So maybe you can write down there are three kinds of stationary points that are in your syllabus. The main test one is mean and max. But then we also have uh say stationary points of inflection. So yeah, wait, let me try to shift this to a side. Okay, nice. Sorry, never mind. I'll just leave it at the side. Yeah, hide the link. Okay, so stationary points, there are three kinds. So we talk about stationary points. I just write down the three kinds of stationary points. We have max point. Max point kind of looks like this. We have mean point, kind of looks like a U shape. Then the last one, we have stationary points of inflection. It looks something like this. So in general, we want to use first derivative and second derivative test to help us determine like what kind of stationary point or like the nature of the stationary point. So this is important. We want to know the nature of the stationary point. So the table looks like this. You kind of need to like remember how to what are the important components, the columns and the rows of this table. Basically, what you're doing is that for any stationary point, we know that the corresponding x value of the stationary point, say the max point, when I have x equals to say this value, I will have the gradient to be 0 because we established just now the stationary points. We have the tangent to be horizontal. So therefore, it's the dy dx is equals to 0. In terms of the slope, it is just a horizontal line. So we need to know that right before this value and right after this value, what is the gradient of these graphs. So we will sub a very small value. Say for example, this value is x equals to 2. I will sub a very small value, say 1.99, and like a value that is on the right hand side. So maybe 2.01, and we want to observe the behavior of dy dx. Is it plus or is it minus? Once we know this, we can establish the shape of the graph. Which is it? Is it up or is it down? From here, we can conclude what kind of stationary point it is. Can? Then the next one we look at second derivative test. Second derivative test is sometimes more useful or like more convenient compared to first derivative. But just know that first derivative works 100% of the time. You can always use first derivative test, and second derivative test there's a risk, which is if you do second derivative test and you see like you get say d square y over dx squared equals to 0, it is inconclusive. So there's this risk when you want to use second derivative, which is if you get your d square y equals to dx squared, you sub in the x value, then you see that it's d square y equals to 0, then you need to go back to doing first. So some polynomials where you see this kind of situation, you can expect this kind of situation now, is that if all terms are a function of x. So maybe like example we see, say 3x cubed plus 3x squared, something like that. If this is your dy dx expression, then it is likely that if I have x equals to 0, I sub in, then say if I have this expression, example, then I want to determine the nature of stationary points when x equals to 0. It is likely that after I differentiate, I sub x equals to 0, I will still get d squared to be equals to 0. So therefore, I need to go back to doing first derivative test. So second derivative test, there's a risk, but I'll just write down here of an exam strategy. Exam strategy, when do you use second derivative? If you see simple polynomials. When I see simple polynomials, I tend to use second derivative because it's easy to differentiate again and sub the x value in. Can so n degree polynomials. First derivative test, it always works. It's a bit tedious, but it's actually okay one. So the advantage of first derivative is that it is always usable. It's just that you need to sub like two different values using your calculator. So say if this is x equals to 2, to sub like say example 1.99 and example 2.01 example. So I press my calculator, find the dy dx value when I sub a value smaller and a value bigger. 可以吗? Okay, can. Let's move on. So equation of tangent and normal. This one the equation you need to know because this is the fundamental equation of like say a line. There are two equations you can use. Y equals to oops y equals to yes, y equals to mx plus c. That's your traditional sec 1, sec 2 formula. The other formula that you have learned, mx minus x1 plus y1. Both are useful in its own ways. The second one is usually more useful because it allows you to bypass finding the y-intercept. So we can straight away use this equation to find, like say, the equation of a line. So usually do that. Observe that, say, a normal and a tangent. Say if I have a curve here and I draw, say, a tangent to this curve, then the normal to this curve will have the gradient to be perpendicular. Perpendicular. So this is normal. This is tangent. And so the gradient of the tangent is -1 over the gradient of the normal. This relationship we'll use it a lot in later the questions like for tangent normal. 可以吗? Okay. Yeah. Last one for chain rule. Chain rule, the questions usually come with like say usually say you write dy dt equals to dy dx multiplied with dx dt. Usually, the question will give you 1. So say the question, out of the two yellow ones, the question will give you one of them. And dy dx, you need to derive from the function of x. So you will be given two things. You will given one of the yellow one, then the question will ask you to find the other. Then you will also be given y as a function of x. You will also be given y as a function of x. Then from here, you need to derive dy dx by yourself now. And you'll be given y as a function of x, then you want to derive dy dx. The question 99% of the time will be in this format. So you'll be given one. Question 1 want you to find this. This is the unknown. So later for question 6, we will practice how do I construct this equation. It's always in a form that is like this. You're given 1. Question 1 want me to find 1. The last piece of the puzzle is basically differentiating the function that is given in the question. So you are given y equals a function of x, then you yeah, okay, can. I go through a lot of exam skills because I'm sure that you already know this topic is already, most schools already finished it. So if you have any queries, just type in the chat. You can PM me also, or you can, at the end of the day, I'll send you this document so that you can refer to my annotations then when you do the question. Can? The first question is quite simple. I'll use it to go through. Then I'll give you a bit of time to try the next few questions. Then I'll a bit of time before I go through lah. So you for those who haven't do, you all can try a little bit first. Usually I'll give a bit of hint before I do so that in case you are lost, you have something to follow also. That's the style that I teach also lah. Can? Here says find the coordinates of the stationary points. This question will be purely going through by me. Then after that I'll give you all questions to allocate time to try the remaining questions. Those who have already done, you can use that time to ask me questions or check your working or uh, ask me anything you want. Can here we have the curve y equals to fx. We want to know the nature of stationary points in this curve. So what I want to do is I must find the gradient function first. Very straightforward, right? So I find dy dx, I'll differentiate the function. X squared when I differentiate, I'll get 2x. For this function specifically, maybe it's more useful for me to write in this form, exponential form. So when I have y equals to x squared plus 4, x to the power of negative 2, the negative 2 is easy for me to apply power rule when I differentiate. So I differentiate the next one. I apply power rule, I bring down negative 2. I have x to the power of negative 3. 可以吗? Okay. Then I clean this up. Maybe I have 2x plus, minus 8 over x cubed. This will be equals to 0 at the stationary points. Okay, then I'll proceed to solve. Can proceed to solve. So the solving part I think is quite okay. We'll get x cubed, x cubed times x, so x4 equals to 4. This will give me x to be equals to plus minus of root 2. Okay, so I know that there are two stationary points. One of them at x equals to root 2 and x equals to negative root 2. I'm interested to know what are the y values because the question say coordinates. Coordinates means I must have x and y value also. So maybe we go and find that first. That's quite simple. We just take the x values we solve, sub inside. Okay? So we say when x equals to plus minus root 2, we sub that in inside y, we'll get the same y value because squared ma. So that means originally if it's plus or minus, it doesn't really matter. Y is equals to plus minus root 2 square plus 4 over plus minus root 2 square. This will just give me 2 plus uh 2 plus 2, which is 4. Can? Both of them will give me the same y value. So therefore, I know the coordinates are root 2 and 4. Next one is negative root 2 and 4. Last one, I want to find the nature of each stationary point. What will I do? In this case, I look at the expression that I have after I differentiate. It is a simple polynomial. So we can always do first, but for this one, maybe I'll do second so that you can see the procedure for second. Later, we'll have a question, the same question, we'll do first. So we have coverage now on both. So this is a simple polynomial. Simple polynomial, we can use second derivative. So second derivative requires us to differentiate again the function. Someone talk. Black horizontal bar blocking at the side. Is it this one? The worksheet is it? Wait, I sent the worksheet in. Wait ah. Wait ah. Give me a while. I send the worksheet in. Renzo, can you PM me on Tele or something? Cause I think a bit hard to send through here. Am I doing the after I finish this question then I send you? Then I think then yeah. Is the bar gone? Or is it still there? Some blocking bars. Is it on top? Wait, I remove it now. The top, right? I think no, should be okay already. Is it still there? Okay, nice. Can continue. I want to find the Okay. Yeah, I think it's just the meeting prompt. So like, cause I share screen with the Zoom. So if got like people text or like got someone join the room, everything, then the prompt will come up. Yeah. Sorry, just bear with me for a bit. The recording won't have this lah. It's just the current thing. Yeah. So yeah, I want to find the nature. If I want to use second derivative test, when I observe that this is a simple polynomial, I'll find d square y over dx squared. Differentiate this one more time lah, huh? So this will be the gradient function I write in the polynomial form. So 2x minus 8x minus 3, something like that. Easier to differentiate lah, huh? So then when I differentiate this, just apply power rule for both. I'll get 2 minus 8. I bring down the minus 3, then this will be x to the power of minus 4. Okay, can. Okay, then here, just yeah, bring the minus 3 out. You have 2 plus 24 over x4. This is an even power, so if I sub plus minus root 2 inside, I will still get the same value lah. It doesn't really change. Can? So I will just say when x is equals to plus minus root 2, sub inside your d square y over dx square value. I have 2 plus 24 over plus minus root 2 square. This will just be 4. 24 divided by 4 is 6. 6 plus 2 is 8. This is positive. So we establish that both are mean points. 可以吗? Graphically, it looks something like this. Graphically it looks something like this, even though you don't need to draw the graph. I just drew it out so that you can see it's something like this. So we have two like minimum values at these 2 points corresponding to x equals to plus minus root 2. The y value is the same, y equals to 4. 可以吗? Okay. Any questions about this? If not, I'll give you a bit of time to try the next question, then I'll go through. I'll send the worksheet as well. I try to send it to the chat, maybe. Take like 2 minutes to try the next question, then I go through. The front part, the email part should be quite simple. Then after that, uh, yeah, we will use this question. No, first derivative always can use, always. So if like in exam you want to see if like you're contemplating like your like which one to use, then just use first. Cause second, right, usually when you see very difficult to differentiate, for example, got product rule this kind of thing, straight away I will just do first. Cause first is consistent, it always works. But second is like there's a risk. So the risk is only like worth it, right? If you see like, oh, it's a simple polynomial, it is faster to do second derivative than first derivative, then you choose to do second. If not, right, just always do first. First is consistent. You know that you invest 2 minutes, you can straight away get the answer. Compared to, oh, simple polynomial is like a quadratic lah, or like you see in our previous question, we see that the point yeah, I sent the worksheet already to those who have PM me. If you need the worksheet also can. The worksheet that I sent is a bit different. It has my annotations inside. So if you are ahead or what, right, you can, yeah. At the end of the class, I'll send that worksheet also to uh to everyone lah. So what is a simple polynomial? Yeah, it looks like something. Maybe you see this. So just now our question we get 2x minus 8 over x cubed. Each term, right, is just a term with a power of x. So it's easy for me to differentiate this again. I don't have to do product rule, don't have to do anything. I just differentiate each term here with respect to x. This is what I classify as a simple polynomial. So a quadratic equation also simple polynomial. Things that is easy like to differentiate one more time, then yeah, those are simple. It is worth the effort to do second derivative. For functions that are like extremely complicated, like this, it is unlikely that you want to do second derivative, even though can actually this question I did second derivative, but I'm just saying that for polynomials where it's very difficult to differentiate, you will tend to do first because first is quite consistent. You spend 2 minutes of time, you just sub the values back and forth. So with the dy dx expression, you just sub a smaller value and a larger value compared to the stationary point value, then you can straight away get the nature already. So that is more consistent, like it's a more efficient use of your time. 2 minutes, you settle. So when you want to consider doing first or second, you think about, can I do this faster than 2 minutes? Can I differentiate it once and sub in faster than 2 minutes? If I cannot, right, then just do first. Okay. Sorry, I yap a lot. That's my yes. Can. We start the E-math part. Front, there's a gardener who wants to wait, I think the bar is this. Okay, yay. Okay. Let's continue. So this one, the email part, I'll just go through quickly lah. But I'll go through the exam skill of like why I do certain things. So I think most people know it's a equilateral triangle. The other is a circle. Yeah. So equilateral triangle, we can find the area very easily of equilateral triangle. The formula we all know: half AB sine C. Can this equilateral triangle, each side is x, and the angle in each is theta. But in this case, equilateral triangle, the angle inside is 60 ma. So straight away, half AB sine C. Then the area for circle is pi r squared. The perimeter of the circle, or the circumference, we can call it 2 pi r. Then for equilateral triangle, the perimeter we can say is 3x. These are all the prerequisite formulas that you need to do, you have for this question. Can? First one, they say he used 20 meters to enclose 2 flower beds. So basically, the 2 parameters of the 2 flower beds add up gives me 20. That's what the story is saying now. So we just add the 2 parameters. The parameter, we add both up, then we will have 3x plus your 2 pi r. And 3x plus 2 pi r gives me 20. Then the question say, can you make r the subject of formula? So we shift the 3x to the right hand side, then we divide everything by 2 pi. R will be equals to 20 minus 3x divided by 2 pi. Done. Okay. Why does the question want me to do this? This question is nice. They guided you to do this. But eventually, right, there's this one thing I want you to recognize, which is sometimes the question won't guide you. All they will give you, right, say if they never guide you, all they give you, right, is the expression. So a higher level for this kind of question is you need to look at the expression and decipher which variable, either r or x, do I need to keep, which variable I want to sub away. So for the higher order questions, what we need to do is to observe the expression we need to show and realize that it has no r inside, no r. So when I have no r, but we see that our sum of areas, there's a r here, ma. The question is trying to lead us to use this expression for r to sub away the r inside this expression. Can? So that's the big picture. So I write down again, what's the big picture? Observe a is only a function of x, no r. There's no r inside the a expression. So the question is trying to lead us to use the perimeter expression, to use expression 1 to sub away the r inside the a expression to give us a function that is only with regards to x. Why does the question want me to do this? Because when a is written in terms of only one function, it's easy to differentiate. To find the nature of the stationary point, I just find dA dx. Instead of dA with respect to r and x. That's too troublesome now. Yeah. And that one use chain rule, very troublesome. So once I express the formula in terms of one variable, easy for me to maximize the area. 可以吗? Okay, can. So we talk about the area. The area is just a sum lah. So while the two expressions just now, A is equals to half x squared sine 60. 60 is the angle inside the equilateral triangle. Then we add the area of the circle, pi r squared. Okay, simplify some things. So elaborating on what I said just now, we want to use the r value, the r expression here, to sub away the r inside the a expression to give me an a expression that is only a function of x. 可以吗? So let's sub. We have half x squared sine 60. You should memorize it as root 3 over 2. If not, can use your calculator to derive. Then the r will sub away. We have pi 20 minus 3x divided by 2 pi. This one has a square on it. Okay, can. Now we just clean up this expression. So here we'll have x squared root 3 over 4 plus 20 minus 3x squared over 4 pi. Can. Here you have pi squared then it cancels out the pi here. So you get 4 pi. So now the last step is observe the answer. I need both of them to be in the same fraction. I have two different fractions now. The denominator should be 4 pi. So I will change the first one into denominator 4 pi as well. So we just multiply pi on top lah. So we have x squared pi root 3 plus 20 minus 3x squared. Then the whole thing will just be divided by 4 pi. Sure. Can 1 minute find the question wants you to maximize or minimize the value of a by finding the stationary point. So the next step is to find the a dx. I'll give you a bit of time to try. Any questions, just say in the chat or unmute and talk. It's okay one. Then once I find my dA dx, I want to equate this to 0 because I want to find stationary points. This will be at stationary points. The gradient is 0. 1 minute to try, then we go through. 3 minutes, a bit longer. Jasper, I just send the worksheet in the group chat. Yes, my annotation's okay, but that's if you want to do in advance, then you can see. Yeah, don't just take my worksheet and leave. Okay, yeah. 2 minutes to try. I sent the worksheet in the group chat already, but it has my own work solutions inside. So I usually do this for my classes as well. At the end of the class, I will just send like the worksheet lah. Yeah. I'll just be here. Any questions you can ask me. Can. So try to differentiate the expression. You are given an A expression here already that we have shown. This A expression, try to differentiate it. Once you differentiate it, try to solve for your x values. These x values, when I equate the dA dx expression to 0, these x values will give me the x values that correspond to the stationary point. Oh yeah, it's the bar for the group chat. Because like I'm not presenting one, so I just leave it there in case anyone texts. Actually, I can remove it. It's the floating meeting controls. Should be okay now, right? Yeah. Not like that if anyone says something I cannot see. How to solve this problem? Shit, what happened? Okay, let's go through. So after we solve we'll differentiate this expression. Here there's a 1 over 4 pi here, which we technically can ignore, because later when we equate to 0, then this I can just divide over, like it's just a constant. What? Uh, okay. Can see, right? My screen. Okay, can. Then, yeah. So once we have this expression, we will differentiate this. The 1 over 4 pi we can just factorize. So I think it's fine. We can just factorize. Then we focus on the numerator here. So I differentiate the x squared, I'll just get the 2 on the outside. Then this 20 minus 3x squared, whole thing squared, we do power rule first. Then we apply chain rule on the term that is inside. So we get negative 3. Yeah. Can? Then we equate this to 0. So as mentioned, the denominator we can just divide across both sides. So we can remove it and we'll have this part. This part we just need to solve for x lah. Make x the subject. So here got two instances of x. We can factorize the x, then we'll divide over. This part just press calculator to get the final answer. Again, this expression over here, it's just a simple polynomial with regards to x. So we just have two terms with respect to x. We can do second derivative. So for this term, I'll show second derivative in the sense that I'll differentiate both terms with respect to x again to get the second derivative, this expression over here, press calculator, clearly it's more than 0 lah, because all the terms are positive. So it's a mean point. Then, yeah, we can see that when x equals to 4.15, it corresponds to a mean point. The question never asks for the coordinates, they just ask for what is the x value. That gives me the stationary point. So yeah, having x equals to 4.15 will do. You don't need to go and find the area because the question asks for the value of x. They never ask for the coordinate or like the a value. Last part, after I find the nature, we realize that at this x equals to 4.15 cm, what I just did is I minimize the area that can be given to me when I have these dimensions lah. So if I have 20 meters of fence, then if I arrange it in such a way such that x is equals to 4.15, what I've done is that I've minimized the area that is inside the and that's inside the enclosed garden, which is realistically speaking maybe not an ideal thing lah. So the last part they say explain why the gardener might be disappointed. This one just logic that thing out lah. It's not very math. So what I said was x equals to 4.15 is the minimum possible area of the enclosed garden. Then this might not be as efficient use of gardening space as desired by the gardener. But this one is just a one mark thing. The main marking point for this is that you observe it gives you the minimum possible area. Then the back part you just English it up. Okay, just think of it as why the gardener wouldn't want this. That's not the main focus. The main focus is this one. The back part is quite flexible. Just give a reason why the gardener would not like a minimum possible area. Yeah. 可以吗？ Okay. There will be one more question behind. That question I will do first derivative so that we have a balance of both lah. So we learn how to do second, and when we can do second when the expression is a simple polynomial. Just just terms in x, that's it. No ex, no sin x, this kind of nonsense. Then simple polynomial, we can just do second derivative and it might be more efficient than first derivative. So simple polynomial. Okay, those who are done can move on to question 3. Then yeah. Then yeah, 3 looks like a line question, right? So I'll just write the formulas on top before let you all try, then I'll go through. Question 2, the back part just English it out, okay? But the important thing is that you must mention it gives you the minimum areas of the equilateral and also the circle. Next. Front part I'll help you before we do the back part. So here says express fx in terms of that form. I'll present like a few methods to do number one. Number one, my favorite method to do is juggling. Juggling is basically trying to create the denominator factor in the numerator. So if I have say f prime x equals to 10x minus 9 over 2x minus 3. In JC, this method is very commonly used. It's just that in lower secondary you would or upper secondary you would do long division. Long division takes a bit of a time, so I will just present this method. If you don't like, you can just do long division, it's fine. So what I want to do is I want to create the factor of 2x minus 3 in the numerator. So say if I have 2x minus 3, if I want to have 10x, just nice divide by it. 2x minus 3, I must times 5 to get 10x minus 15. So I'll artificially create the 15 here, minus 15. I'll artificially create the minus 15, but I cannot just create something out of thin air. So I will compensate by adding a 15. Then the 9 is originally there lah. Then this one, the whole thing, I will divide by 2x minus 3. Okay, once I have this, then this can just nice divide by this to give me 5. So 10x minus 15, just nice divide without remainder. 2x minus 3, I'll get 5. Can? Then 15 minus 9, it will just give me 6. Solved. So therefore, my A is equals to 5 and my B equals to 6. Okay. The next part, I want you to analyze this expression. Then the range that is given to me in this question, the domain of the function is x more than 3 over 2. So that means only x more than 3 over 2, the function exists. Before that, don't have. So the smallest value of x in this case is 3 over 2. You consider x 3 over 2 and greater. For the gradient function, how does it affect the gradient function? Does it cause the function to be does it cause fx to be strictly increasing or decreasing? 1 minute I'll go through, then we repeat the same for f prime prime x. When we analyze f prime prime x, we are trying to analyze whether f prime x is an increasing or decreasing function. Because f prime prime x is the slope of f prime x. So in case anyone is confused, I write here, f prime x is the gradient function of fx. If I look at f prime x in the same lens, f prime x, if I look at f prime x in the same lens as your here, then your gradient function will be f prime prime x is gradient function of f prime x. So for part 3, when we consider f prime prime x, then we are trying to find the gradient function of f prime x. So therefore f prime prime x lah. Yeah, if in case anyone is confused. Yeah. 1 minute, analyze your f prime x expression, determine whether fx is a increasing or decreasing function. Then we do the back part as well. Then let's go through. So we analyze the expression for f prime x that we found. When x is increasing, so for all values of x, there is more than 3 over 2, this value will be positive. This value is clearly positive. 5 is a constant. So therefore, your entire f prime x will just be positive. So I say as x increases from x equals to 3 over 2, the entire gradient expression must be positive because positive, positive. So therefore, fx is a increasing function. 可以吗? If you want to analyze it very methodically, we can say that for x more than 3 over 2, we can say that this is positive. Therefore, 5 plus that will be more than 5, which is clearly positive. Okay, that's another way you can explain it. Therefore, if the gradient is always positive, fx is an always increasing function. Do the same thing for f prime prime x. We differentiate f prime prime x again. Then we start with this expression. Maybe it's more useful to write it in exponential form. So we have 5 plus 6, 2x minus 3 to the power minus 1. Differentiate this, and we'll have this expression. Once I differentiate, do the same analysis that we have done for this part. We see that the bottom is a squared term. Squared terms are always positive, and in this case cannot be 0 because it is in the denominator. So we will have squared term being more than 0. 12 over the squared term clearly always is more than 0 because 12 is a positive number. Then when we implement the negative sign, that will just get my f prime prime x expression, and it will be strictly negative. So if we prove that f prime prime x is strictly negative, it shows me that the original f prime x function is a decreasing function for my x more than 3 over 2 lah. Okay. So when I find that f prime x is a decreasing function, the implication on fx is that fx is increasing at a decreasing rate. Yeah, because f prime prime x is the gradient of my f prime x. Those who are done with this can move on. Any questions can ask me also. Usually when I go through a question, I have all these small exam tips at the side. If it's useful for you, you can copy down. If it's already intuitive or it's like stuff that you already know, then it's okay. Yeah. Move on. This is a curve kind of question. Here says find the equation of a normal at this curve, at this point. I'll just write the curve equation first, the general curve equation, y equals to mx minus x1 plus y1. This is the curve equation of a straight line. So there are two forms. The mx plus c1 not very useful here. We use the linear one. So y equals to mx minus x1 plus y1. x1, y1 is a known point. M is the gradient of the line. M is gradient. Then x1, y1 is any known point that I know in this line. Known point. Can? Okay. So when I want to know the equation of a normal to the curve, based on this equation that I've written, we see that we need a known point, we need the gradient. So if we need the gradient, we need the gradient function now. So I need to find dy dx. Once I find dy dx, I take this x value, I put inside, then I'll get the gradient. For a line, the gradient is constant. So once I sub in, the gradient will be consistent for the entire line. I also need to use this x equals to pi to help me find the y value when x is equals to pi. Okay, 1 minute try. Then the back part, same thing, is a differentiation kind of question, but here we need to use product rule. So product rule means I have two different functions of x. How do I differentiate using product rule? Say one of them I say is u, the other one I say is v. So if I use product rule, I have d over dx uv equals to u dv dx plus v du dx. Can I differentiate one, keep the other constant, then I plus differentiate the other, keep one constant. So it doesn't really matter you differentiate u first or v first, because at the end of the day you just plus both of them together. But just know that when I differentiate one, the other function of x I keep it constant. Then I multiply to the derivative that I got. Then repeat for the other, plus the two results together. That's for product rule. Can? Here they give you a minimum point at x equals to -1. So when I solve for the two different coordinates of stationary points, the x equals to -1 I reject, don't even need to prove the nature, because the question already say. So I just only prove for the other one that I found. Can? 1 minute I'll go through A, then 2 minutes later from that I'll go through B, so that you got a bit of time to try. The hint I kind of give already. Let you all try a bit first for those who haven't done yet. Okay, let's start. So we have y equals to e sin x. We need to find dy dx. Dy dx will be, when I differentiate an exponential function, step 1, I copy it first. And then I'll differentiate the exponent. So sin x, the derivative is cos x. I'll just write cos x. Then we are done. So I need to know when x is equals to pi, what's the value of dy dx, what's the value of y. So y will be equals to e sin pi. Sin pi is just 0. So e to the power of 0, we get 1. Can dy dx, if I sub in, I'll get e to the power of 0, which is 1. Cosine of pi is negative 1. So I'll get dy dx. This is e to the power of sin pi, cos pi, right? Cos pi is negative 1. E to the power of 0 is 1. So this is negative 1. Take note that this is the gradient of the tangent. Gradient of tangent. But the question is asking for normal. Okay, so back to the summary from just now at the start when we go through, how do I find gradient of normal? It is negative 1 over the gradient of the tangent. So going back to this question, here we see that we need to take negative reciprocal of the gradient of tangent. So I write down gradient of normal will be equals to negative 1 over negative 1. That will give me 1. Once I get this value, I can just plug it into the general equation for the equation of line. So I'll have equation of normal to be y equals to m x minus x1. x1 is pi lah, plus 1. Can? When x is equals to pi, the y value is 1. The gradient of the normal also is 1. So easy lah. Huh? So we have x minus pi plus 1. Okay, so the equation of normal is y equals to x minus pi plus 1. Next part, product rule. I'll just go through quickly. I'll differentiate the first term first. So say we have x cubed e 3x. I differentiate x cubed first. I'll get 3x squared. Then the next one just copy. Next, I'll keep x cubed constant. Then we differentiate e 3x. e 3x, when I want to differentiate, I'll just copy. Then I'll differentiate the exponent. 3x, the derivative is 3. And here we have a common term, e 3x. I can just factorize that. e 3x is a strictly positive term. e 3x is strictly exponential functions, strictly positive. So when I have this part, when I equate to 0, this is a strictly positive term, just a constant. Basically, I can treat it like a positive constant. I focus on when 3x squared plus 3x cubed equals to 0. And we solve, we will get two different values of x. Here, x equals to minus 1 is expected. It's one of the minimum points that the question already stated. So I'll reject that. I focus on x equals to 0. For this expression, right, if I continue to differentiate this, I'll get like 6x plus 9x squared for the polynomial part now. I sub x equals to 0, my d square y will definitely be 0. So it's an inconclusive situation. It's not very useful, even though it's a simple polynomial, yes. But using just like a short analysis or observation, we realize that when I differentiate this, I sub x equals to 0 inside, I should get my derivative to be 0. So it's not very useful to use second derivative. Let's do first derivative. So first derivative looks like this. If I have x equals to 0, I sub a small number. Example, negative 0.01. Example, positive 0.01 into my dy dx expression. Use the calculator to help you so you don't have to, so these x values here, I highlight, just replace it with a small value on the left and on the right of x equals to 0. So sub these values inside one. Can? Once you sub, then from there you'll observe the sign. Both of them should give you a small positive value. which means that the slope is both upward sloping. This is rarely tested. Usually 99% of your things in your exam is max point or mean point. For this question, it is a stationary point of inflection. The question is asking for the coordinate. So let's sub x equals to 0 into my y expression. Your y expression based on the question is y equals to x cubed ex. So y equals to x cubed e3x. Our sub x equals to 0 inside. Clearly you get y equals to 0. And so therefore we say that 0, 0 is a stationary point of inflection. It's an upward sloping. Yeah. So if you look at the shape, it looks like this. So graphically, it will look something like that. 可以吗？ Any questions, let me know. If not, we move on to 5. 5 and 6 are quite okay. 6 is a chain rule question. So can practice the skill set that I was mentioning just now. Lah. You are given one, then the question one, you find the other. Optimization, we practiced 3 times already. I think generally it's the easy part of differentiation. Like 90% of people will get it right one, in the sense that it is a very straightforward process. You find dy dx, determine the nature, find y value, submit answer. It's always the same pattern, the same workflow. Let's move on to 5. 5 got a bit of crossover with quadratic uh, polynomials. So stuff that you learn are like, for example, the question say, find why is there only one value of k that y cannot be negative, this kind of thing. So clearly it's a discriminant kind of situation. Later we'll go through, we just go through the part about differentiation first. So here says the equation on the curve is y equals to 2x squared plus k plus 2x plus k. K is a constant. When k is 5, show me that the line is tangent to the curve. Can I give a bit of context for this? Line and curve only got 3 ways that they can interact. Okay, 3 ways. So line and curve interaction. Case 1, the line and the curve don't intersect. Can? 0 intersection. Can? Case 2 is when you have 2 intersections. This is not for all like curves lah, but just for quadratic curves. So yeah. So we have say two intersections. And maybe I write a bit clearer quadratic curve interaction. So this one is 2 intersections. And last one is only 1 intersection. Can? 1 intersection. 1 intersection is when the line is tangent to the curve. So here they say show that the line is tangent to the curve. So this is when tangency occurs. Can? Is case 3. So when the question say, can you show me that this line is tangent to the curve? Essentially what it's saying is, show me that the curve and the line only intersect at one point. Can? Show me that the curve and the line only intersect at one point and is at the point of tangency. Okay? We sub k equals to 5 inside first. We have y equals to 2x squared plus 7x plus 5. Then the question basically wants you to show them that y equals to 2x squared plus 7x plus 5 only intersects the curve y equals to 19x minus 13 at one point. Okay? 1 minute try, then we go through. So in other words, right, if I equate them and solve, if I try to solve for intersection, I should be only able to solve for one real intersection. That's the hint. It's a bit linked to quadratic polynomials. The back part also later. So we try to equate. So we say where curve and line intersect, we will have 2x squared plus 7x plus 5 equals to 19x minus 13. Clean this up a bit. We have 2x squared minus 12x plus 18, which is equals to 2x squared minus 6x plus 9. This is in your nice formula where you have x minus 3 squared. Can? If we attempt to solve this, we will just get x equals to 3. Is the only intersection. Is the only intersection. Only got one intersection. We are assured that it is case 3. Can? The question wants me to find the coordinate of this intersection. I will sub x equals to 3. I will get y equals to 2, 3 squared plus 7, 3 plus 5 to give me 44. Can? So we have 3 and 44. Next, y cannot be negative. This one I'll let you all try a bit, but I'll just give a bit of hint. This one a bit tricky. Cannot be negative, right? There are 3 situations that a number can put itself in for now. Real numbers can only be negative, 0, or positive. So when I say cannot be negative, I'm saying that yes, can be positive. Yes, can be 0. Can be. Can be. Okay? So for part 2, the clue I can give you is we have y, which is 2x squared plus k plus 2x plus k. This is more than or equals to 0. So just cannot be negative, can be 0, can be positive. Then how do I have this equation to be equals to 0 or more than 0? More than 0 is a strictly positive situation. Equals to 0 means cuts the x-axis. Okay, got 2 situations. So think about what does this link with the discriminant. So say if it's strictly positive, what can I say about the discriminant? If it's equals to 0, then I'm basically solving for the solution for this equation. What can I say about the discriminant? And let's go through. When y cannot be negative, y can be equals to 0, or y can be positive. When y is positive, it is strictly positive. It has no real roots. When y is equals to 0, we can solve for the solution of the curve to find real roots. And so we say for y to have real roots, for y to have one or no real roots, because y cannot be negative. So y is positive, strictly positive means no real roots. And equals to 0 means yeah, maybe have 1 or 2 real roots because it's a quadratic. So for y to be strictly positive, I must have no real roots So that means my discriminant must be b squared minus 4ac must be less than 0. Can? For y to be equals to 0, then I must have real roots for this situation. It can be equals to 0. So if I combine these two scenarios together, I'll get something like this. If it's strictly positive, the coefficient, clearly we see that it's 2. So it's a smiley face, strictly positive. The discriminant can be less than 0, can also be equals to 0. We try to solve this, we'll end up having a squared term that is less than or equals to 0. So squared term clearly is positive so it cannot be lesser than 0, which means that the only possibility is for the squared term to be equals to 0. So therefore, k equals to 2 is the only value that can satisfy the inequality. Because inherently squared terms can only be positive. This part not very differentiation, it's very quadratic polynomials kind of situation. The thing that you need to recognize is that for y to not be negative, y can be equals to 0, which means that there is solutions, there is intersections with the axis, or y can be positive, which means that this polynomial is strictly positive. A strictly positive polynomial has no intersections with the x-axis. So there are two situations you are combining to one. First one is when it intersects the x-axis, that is when y is equals to 0. Next one is when y is more than 0. That is strictly positive. This comes from the base understanding that when a polynomial cannot be negative, it can either be positive or 0. It's a very quadratic polynomial thing. This question I focus more on the front part because the back part is not really differentiation. But if you have any queries for this, can ask me. I admit it's quite confusing. If okay, let's go through the last one before we end. So the last question is question 6. It's a chain rule question. So I'll reinforce the understanding a bit before we try. I'll give you a bit of time to try, then we go through. Can? So for 6, there is a circle in an equilateral triangle. Then they say that both the circle and the equilateral triangle, the sides so the radius and the side of the equilateral triangle, they are increasing at the same rate of 0.2 cm per second. The side is called x for the equilateral triangle. The radius of the circle is called r. The initial value of x is 10 cm. The initial value of r is 3 cm. And x and r are changing at the same rate. They are both increasing by 0.2 cm per second. Can? So in that sense, right, x and r, they are always 7 cm apart. So because they are increasing at the same rate. So if I have x, I say that x and r, x is 10 cm, r is 3 cm. No matter how much x increase and r increase, they increase by the same amount. The difference will always be same, which is 7 cm. Because they increase at the same amount. Okay? So here says express x in terms of r and show that a is this expression. Here, right, we observe that the a expression has no x. There's only r. But if we want to express the area of the shader, clearly we need to write a function of x and r. So the intuition is that once I get my expression for x in terms of r, I will sub away my x to give me a function purely in terms of r only. Okay? Yeah, this part a bit difficult, I'll go through. So then the rate of change part, I'll give you a hint, then you can try. So for A, right, we talk about the areas of these two. The difference of the area of the equilateral triangle and the circle will give me the shaded area. So we have A to be equals to equilateral triangle half AB sine C minus away the area of the circle. And okay, so here, right, when I clean this up, sine C is, sine 60 is root 3 over 2. We'll get root 3 over 4 x squared minus pi r squared. We need to find a relationship between x and r so that we can sub away this x and just have an equation purely in terms of r. The expression that we know between x and r is just that they have a difference of always 7 because x and r increase at a rate of 0.2 cm per second. They increase at the same rate. So no matter how much they increase, how much time has passed, their difference will always be 7. It's like two runners that are 7 meters apart. They run at the same speed. They will forever be 7 meters apart. So from here, we can observe that x is equals to r plus 7. And then we sub that in. Here is root 3 over 4 r plus 7 square minus pi r square. And then we are shown. Last part, before you try, I'll just give a bit of clue. Here says find the rate of change of shaded area. This is talking about dA dt. And the question wants me to find dA dt. So we want to find dA dt. Then we are given a as a function of r. So in the grand scheme of things, this is a as a function of r. So from here, if we differentiate, we'll get dA dr lah. Okay, then the last one, I want to find dr d. From here, the last thing that connects the piece of the puzzle. So say if I have a, I want to have t here. I want to have dt here. Clearly my dr need to cancel out, right? So I have dr. Newton says you can treat this chain rule as a fraction, even though technically it's not lah. It's not really a fraction. dA dr and dr dt, they're not fractions. They are derivatives, but there are proofs that say that you can treat these two like fractions. So it's as if lah, your dr is cancelling out, as if, but it's not the case lah. So yeah. So based on this, once we fill in the missing piece of the puzzle, this one we know is 0.2. From here, we should be able to calculate dA dt. How do I get dA dr? We use a as a function of r. Use a as a function of r to calculate dA dr. 可以吗? Okay. 1 minute try, then I go through, then then we'll end already. Then if you have any questions, can let me know. I will send you the annotations as well. Actually, I sent already. It's inside the group, the Zoom chat. Let's go. So let's talk about this. We have a equals to this function. We differentiate a equals to root 3 over 4 r plus 7 squared minus pi r squared. Differentiate this expression in respect to r. We'll get something like this. Go through the differentiation a bit. First one is just power rule. We bring down the 2. Then yeah, then we are done. So r plus 7. Then pi r squared we differentiate. We'll get 2 pi r. Okay, clean this up a bit. Then, yeah, if I want to find the value of the rate of change of shaded area after 20 seconds, I need the radius after 20 seconds because this function is only in terms of r. Then I can't sub in, right, the value of 20, this t equals to 20. So here, right, I have an additional problem, which is I need to know when t equals to 20, what is my r? What is my r value? 可以吗? So once I know that, then I can sub in. Luckily, we know that the initial value of r is 3 and r increases by 0.2 cm per second. So after 20 seconds, r increases by 0.2 cm per second. I start with 3, then I just add 0.2 times 20. From here, we should get the value of r when t equals to 20. 可以吗? This will give me r equals to 7. Once I know r equals to 7, we can plug this value inside here to find the value of the ADR when t equals to 20. Because I know that when t equals to 20, r equals to 7. So I take this r equals to 7, sub inside this expression. Go back to the expression that we talked about just now. The a dt is equals to the ADR when r equals to 7 times the r dt. The r dt is constant at 0.2. The ADR, I just sub in r equals to 7, I should get my expression. Then this is how I just press calculator, we'll get negative 6.37 cm squared per second. Area, the unit is cm squared, time the unit is second. Therefore, we get this expression. What does this mean? Like in the grand scheme of things, it means that when in this figure, oh, okay, can. So r equals to 7, so I just go back to the premise again. Sorry. I go back to the premise why I want to get r equals to 7. So we start with, after I differentiate a, I get dA dr is this expression over here. Can I get this expression over here? If I want to know what is the rate of change of shaded area after 20 seconds, I need to know what is dA dr after 20 seconds. But this function is not in terms of t. There's no t here. I cannot sub t equals to 20 inside. I need to sub a value of r when t equals to 20. So I need to read the question again, find out what is the value of r when t equals to 20. The question says that r has an initial value of 3 when t equals to 0. R equals to 3. R increases at 0.2 cm per second. That means every second r grows by 0.2 cm. So if I start with t equals to 0, r is 3 cm. If I increase by 20 seconds, and the rate of this increase is 0.2 cm per second, I can calculate what is the value of r when t equals to 20. Because every second, r increases by 0.2 ma. So after 20 seconds, r will increase 20 times 0.2. That is the total of 4. 4, I plus 3, I'll get 7. And, okay, go to the back part. Okay, yeah. Then once we sub in, I was elaborating the grand scheme of things when I have dA dt to be equals to negative 6.37 cm squared per second. What I'm trying to say is that as this expands, when x and r expand at the same rate, what happens is that the area will decrease because even though r and x increase at the same rate, r is the radius. So it contributes to a larger area of the circle faster compared to the area of the triangle. So even though x and r increasing at the same rate, the area of the triangle increase slower than the area of the circle, just because of the formula lah. This is pi r squared, this is half AB sine C. So because of this, then it will cause the shaded area to decrease because the triangle increase at a slower rate compared to the area of the circle. Can, so therefore we have our dA dt to be negative because the shaded area is decreasing in size. Eventually, it will reach a point where the circle outgrows the triangle lah. Yeah. Can? If no questions, then we'll end here. Then I hope you find this WA2 revision useful. Then in case you have any more questions about differentiation or any other topic or like my classes or overmarked in general, you can just reach out to me on WhatsApp or like in the class chats lah. Then you can also like reach out to the respective channels for overmark. If you need extra materials to prep for any topic, can let us know also. I think most tutors will be happy to facilitate lah. And thank you. Okay, if nothing, no questions can leave already. Bye bye.